Hello, I'm Hưng. So now I'm going to actually let me introduce myself first. I'm a software engineer with around 5 years experience. Currently, I'm working in Japan, previously Shopee. So I work mainly on the backend side, but I also done several projects in the front end side using React. Yeah. So let's go over the real-time vocab quiz design. So first, let me just go quickly through the requirements. So basically, from my understanding, there are two main requirement types. The first is functional, which we want to allow multiple users to join a quiz and compete with each other. And the quiz would have a leaderboard with scores and with score updated in real time and visible to the users in the quiz. This I have also make some assumption, which we will go over in the assumption part. So the non-functional requirement is actually pretty standard. We have scalability, performance, reliability, maintainability, and observability requirements. Yeah, so let's go over to the assumption I made in addition to the functional requirement, so that we can start making a workable system. So the main assumption that I make is that the system will have the functionalities quite similar to the Kahoot system. We will have a fixed amount of time for each question, and the quiz will end after all the question ends. And the leaderboard will be updated each time a user answer a question correctly. Because if they don't answer it correctly, then the score isn't updated, and the leaderboard would be updated anyway. So yeah, that's it. So let's go over to the solution overview. The first part I want to cover is the main system component part. So in this part, I list out the main logical component necessary to implement the feature. This is independent of the deployment technology and also the organization, for example, in a single repo or as independent microservices. So here we have the two main actors that will be interact with the system. We have the quiz creator, which will manage the quiz content and start the quiz, and we also have the quiz participants who join in ongoing quiz and compete with each other. So these actors will interact with the front end. So the first functionality required would be the user management functionality, which provide authentications, role-based management. And we also have the quiz content manager, which allows the user to manage quiz. And we have the user database and quiz database to support those services. For the real-time functionality, I designed a quiz controller which controls the quiz session. This controller is stateful, which manages the bidirectional connection and also the user session data in the quiz. So there is also a layer for load balancer behind the stateful quiz controller, which allows scaling the backend system to expect millions of ongoing active user sessions. So yeah, I'm going to implement mainly the quiz session controller and blocking the other one. We also have a simple front end, a simple command line application to simulate the front end functionality. Oh, by the way, in order to allow the quiz controller to scale, I designed the instances to be able to communicate with each other via the event broker. So let's say a user submit a correct answer in one instance, the other instance can also know about the chain and push the leaderboard, so that the other participant connected to the other instances can also see the chain to the leaderboard. And for the leaderboard implementation, I use Redis, which provide a quite simple interface to for such a real-time leaderboard functionality, but we can also consider the technology. So here I have a list out the components and which are basically what I have just talked about. So let's go over to the data flow. Here I list out the detailed flow for each of the required functionality, including quiz content management, login and joining quiz, quiz competition, including load balancing the connection across different instances, and also starting the quiz answering the quiz question and get the score and leaderboard updated in real time. Each of the flow will take a lot of time to cover, so I won't go into the details. But basically, the most difficult part is answering quiz question and also updating the score and leaderboard in real time. So the basic idea is that after each participant answer a quiz question, we check for the check whether the answer is correct and also the question is in progress, and then we will update the score to the database and send out a notification to the other servers. So the other server instances will receive the notification and also the leaderboard information and push out the leaderboard information to the all of the front and client connects to those server instances. So the final part is ending quiz. This one is also pretty simple, and there's a detailed diagram here, and I won't go to that. There are some decisions regarding technology and tools. So I think a detailed discussion of this would be out of scope of this cover, but the main reason I chose this technology first, of course, it could be familiar with me so that I can implement those in a reasonable amount of time. Also, I think the technology here is pretty standard and has a strong community support and also good production performance, proven performance, including WebSocket, Golang, Kafka, Kubernetes, Redis. Yep. So I think one important part we would like to cover is design consideration regarding scalability, performance, reliability, and maintainability, also observability. So here I list out the main scalability consideration. I think the most important part we want to the most important bottleneck of this design is mainly the stateful quiz instances, the quiz session controller instances. So I have already designed it so that we can scale the quiz instance using a load balancer and event broker. In the performance section, I list out some optimization, for example, in the quiz database using a cache layer, quiz binary data if say any using a CDN, and also improving the network round trip to the clients. For example, using data replication across different regions and routing based on geolocation. Reliability, also standard technique, data replication, load balancing, hot replica, and the quiz session scheduling is what I haven't designed here, but I want to highlight that preferably we should use a workflow platform such as Temporal to reliably execute the quiz loop. Regarding maintainability, I think the important things we should note is documentation and also design decision and refactoring evaluation during the evolution of the product. Observability, also standard enterprise monitoring technique, including logging, aggregation, searching, monitoring dashboard, and alerting, and also user analytics. Yeah, I think that's about it. That's all about the design session. So I'm going to give a quick demo of the implementation. I'm going to run two servers, two clients. Let the clients connect to the servers and start the quiz, and then we can see that the server can communicate with each other and can push the update to the clients. Each time a client submit a correct answer and the leaderboard get updated. So yeah, let's start. I'm going to start the first server on this port and the second server on this port. And now I'm going to start the clients and let them connect to the different server instance. Let's use user ID 1 for this one. Second, user ID 2. Now I'm going to start the quiz using a start endpoint. The Kafka broker has already been started, so the server can communicate with each other. So here we can see that the client has get the quiz data from the server, and the server coordinator loop inputs answer to each client. After I answer the question on the client side, you can see that the leaderboard gets updated and puts to each client. The quiz has only 3 questions I designed so that it can be quick. So here, after the quiz has ended, we can see that the leaderboard, the final leaderboard, has also been boosted to each of the clients. So yeah, that's it for the demo.